Welcome back to my channel. In this video, we are going to focus on this problem. It's a problem involving logic gates, and to solve this problem, we'll be using some of the idea of the Morgan's law of logic gates and even some of the basic properties of it. So if you haven't watched my video on the Morgan's law of logic gates, kindly click on the video that is pop out, or you check out the link of the description of this video. In the video, I explain everything you need to know. So first, let's begin with the solution of the problem. So what should be our first step? Now, what I want you to know is that in a case whereby you're having a problem like this, don't solve inward, solve outward. Start from outside and solve inward. But don't start from inside and solve outward. Not that you won't arrive at the same answer, you will, but it's just that solving from outside inward is quite much more precise and straightforward. You won't get stuck. There won't be a point whereby you'll be like, oh, what should I do next? But when you are solving inward, that is, you are starting from inside to outside, sometimes you might get confused, you might not know what to take next. So it's just an advice and a recommendation. So let's begin. Now we can see that this is one input as a whole, and this is another input as a whole. And the relationship between them is that they are adding one another. And over them, we're having a bar. Now, according to the De Morgan's law, when we're having the sum of complements, then we can replace them with the product of the complements. So, which implies that if we are to eradicate this red bar, that is to simplify it, not to eradicate it anyway, just to simplify it, then this turns out to be A plus B times C bar. First, I'm trying to repeat everything. Okay, so with the bar will definitely be equals. Okay, that's addition, not product. So will definitely be equals to A plus B times C, then with a double over bar, I'm trying to split the bar, and that's going to be multiplying the addition returns to the product. So we're multiplying AB to the bar, then with double over bar. Now the next thing we need to know is that when you are having double over bar, you need to know that the result will simply be the input. The over bar will cancel each other. So what am I saying makes sense? Let's find a reference to this. Assuming A is equals to 1, it's normally news that A bar will become 0. Now, if A bar is 0, what will be the value of A with double over bar? What will that become? That means the opposite of A bar. And the opposite of A bar will definitely be 1, since logic circuit can receive more than 2 inputs, which is either 0 or 1. So definitely the opposite of 0, if it's receiving it as input, will definitely be equals to 1. I believe you got that. That's just how it works. So let's move on. If that is the case, then these two pairs of inputs can result in their basic input back. So which implies that A plus B times C bar, okay, that's double over bar, then multiply by AB bar with double over bar will result in, so these two bars are going to cancel off, and left over we have the input A plus B times C. Okay, let me just remove the parentheses anyway, BC. Then this is multiplying. This double over bar will also get rid of each other, and that will become A B bar. So right now, what should we do next? The next thing is just to distribute according to the distribution property, because we are having, as if we are having BC, then to be multiplying AB bar. So right now, I will distribute this input for each of the input we are having within the parentheses, and that will become A times A B bar plus BC, okay, times AB bar. Now, in the video I'm talking about, we discussed about something like A times A. Keep in mind, A times A will result in A, so that will be A B bar plus. Now, what about this compound expression? What would that be? In a case whereby you are having an input to be multiplying its conjugate. Typically, it's negation. Typically, it's not output. You can see the bar. Kindly keep in mind the result is going to be 0. Now, I'm going to show you why. Assuming a is 1, the negation of 1 is 0. 1 times 0 is indeed 0. Assuming a is 0, the negation of 0 is 1, and 0 times 1 is 0. Therefore, in all cases, when dealing with problems involving logic gates, a times or input times its conjugate will always be 0. So therefore, this whole expression will then therefore be 0. And final answer to this problem is AB bar. And this is our final solution. Hopefully you understand the property and the process, and I believe you find this content helpful and understanding. If you haven't subscribed to my channel, please do subscribe to my channel. If you find this helpful, like I said earlier, you can give it a thumbs up, and that will help me reach a lot more audience out there. Thanks for watching. See you guys in the next video. Bye for now.